After discussing power system protection and voltage transformers, we now focus on current transformers, offering practical insights. We discussed the latest devices, CBC100 and CT Analyzer. The Sfaker device was time-consuming and inaccurate. Modern devices complete CT tests in weeks and full tests in under a minute. Traditional testing faced issues like high current injection and CT ratio accuracy, especially in metering CTs, due to conversion errors and load variations. Before concluding the CT tests, it's essential to discuss the latest devices like the CBC100 and CT Analyzer. Previously, the Sfaker device was used, taking months and lacking accuracy. Modern devices now complete station CT tests in weeks and full tests in under a minute. Traditional testing faced issues like inaccurate CT ratio measurements due to conversion errors and load variations. High variable loads could damage CTs, leading to inaccurate reports. CT tests for the station have now become complete in just a few weeks, and full CT tests take less than a minute. There were many obstacles and issues during testing with traditional devices. For instance, when injecting high current on the primary side and measuring this current on the secondary side, while checking the CT ratio, there wasn't enough accuracy, especially in metering CTs due to the error rate during conversion and not accounting for load variations. Another issue is when applying a variable load for testing. In some cases, especially when the value is high, this value can be enough to damage the CT during the test, leading to a report stating that this CT is faulty. When it comes to CT calculations, another issue arises when applying a variable load for testing. In some cases, especially when the value is high, this value can be enough to damage the CT during the test, leading to a report stating that this CT is faulty. Historical behavior without considering what is happening inside. There are such black box testing methods that exist, and they differ in their comprehensiveness and the effort they involve. Primary current injection, portable high current source. Positive, materials using a free content. Finding high quality materials. On the first side, using higher quality materials, writing materials, and mailing materials. Finding high-quality materials on the first side using higher quality materials and comparing them with high-quality materials on the second side can help identify and compare different writing materials. A comparison and custom scent must be achieved to achieve it. This method is not effective. Injecting voltage on the secondary and measuring on the primary confirms correct CT core and tap connection. It does not utilize the differential function correctly, as it should be externally. Very act to inject voltage on the secondary side and measuring the voltage induced on the primary side allows confirmation that the protection or measurement circuit is connected to the correct CT core and tap. Since it uses the differential function, it doesn't utilize the differential function correctly, as it should be done through external layouts. In addition, it cannot plan the function correctly as intended. In the planning functions, 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 planning functions. The inspiration, the revival of a nation. Here it cannot be tested since applying more than 4 kV to the CT's secondary winding. The difference between modern and old testing devices in CT and VT tests. The CT analyzer works by applying a rated frequency voltage until 100 V, then gradually reducing frequency from 50 or 60 Hz to millihertz or 0. This means the voltage becomes like DC, quickly driving a CT into saturation. It calculates the knee point, then raises frequency back to rated. The goal is to avoid high voltage for knee point testing, preventing CT winding breakdown. Instead of increasing voltage, we reduced frequency. This is the low frequency method. Previously, we increased voltage to reach the knee point. Now we lower frequency. Recording CET allows more investigations than traditional devices. The goal of this discussion is to avoid applying any high voltage for testing the knee point, fearing any breakdown on the CT winding insulation. Instead of increasing the voltage, we reduced the frequency value. And this method is called the low-frequency method. It's like in the past we used to increase the voltage until we reached the knee point, but now we've pulled the knee point towards us by lowering the frequency. Recording the CET enables investigations. The CET's fundamentals are in its diagram, guiding investigations and measurements. It determines the CT's behavior for protection and metering. All the fundamentals of the CET are discovered in the cross-sectional diagram of the CET, and then the CET investigations are carried out for the investigations and the meters. It shares its own DC resistance and confirms the magnetic result by sharing the attack resistance. First, it shares its own DC resistance. Then, knowing its own DC resistance, shares the attack resistance to confirm the magnetic result in the core. And the magnetic characteristics of core. Technology. The core group operates with safe low voltages of up to 120 volts. Instead of improving the motor further, it shortens the core if it needs a higher magnetic flux. Finally, it compares the turn ratio with different team procedures.
The CT testing using the low-frequency method was one of the main reasons for initially linking the handling of the CT analyzer so clearly, as engineers believe that CT testing does not occur with normal real values and that the Nebo point test does not reflect reality at all, which is done in the CT analyzer. With the RCT test, the excitation curve, the 10 ratio, and the polarity test, all done with a single connection in just 1 minute, the CT analyzer then performs demagnetization to eliminate any reminiscence flux inside the core to avoid any issues with the CT's performance. All the tabs on the CT must be tested, and there is a switch box that comes as an accessory with the CT analyzer upon request. This switch box connects all the tabs and tests them at the same time without the need to change the tabs each time. Second transformation apps work with others, enabling reuse and repurposing. Secondary transformation applications handle different transformation applications, and so on. Related applications like these allow for reusing the applications you use and repurposing them. Different applications. Related applications like these allow for repurposing different applications. Linked applications like this allow for different applications to be reused. Linked applications. This allow for different applications to be reused. All tab combinations can then be tested in one test, run automatically and efficiently. Before achieving this, social communication is key to ensure that all connections have been made correctly for social media devices in a key way, like achieving social communication in a key way, 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 in a key way. It helps making the correct connections. Connect voltage wires inward to S1 and S2 and current wires outward. If accessing P1 and P2 on the CT's primary side is difficult, connect one point and close the earth switch for the other. CT analyzer uses voltage, not current. When testing one tab on a CT with multiple cores, work only on the core being tested. If issues arise during bushing CT tests, short circuit uninspected cores and ground other phases. You can also test the VT using the CT analyzer with these connections. If there is more than one core inside the CT to be tested, do not forget to work on the core that is not being tested. While we do not work on the rest of the tab, if we are testing one tab on the same core, if you encounter any issues during the bushing CT tests, you should short circuit the remaining cores that are not being inspected, in addition to grounding the rest of the phases to avoid affecting the readings. It's also worth mentioning that you can test the VT using the CT analyzer according to these connections. For more details, you can refer to the manual. The CBC device is used for testing CT, VT, power, and distribution transformers, and it has the capability to inject high currents in the primary up to 400 amps DC or 800 amps AC, and it can also be increased through the current poster up to 2000 amps. It also has the ability to test optical CT according to international standards IEC 61850, but it performs each test with a separate connection. What sets the CPC100 apart from the CT analyzer is that it tests the CT with real current values at rated frequency. However, what makes the CT analyzer special is that it performs all tests with just one connection, and within a minute, rise of a nation.